Why be random? What is it about chance outcomes being random that makes random selection seem fair? Two things. Nobody can guess the outcome before it happens. When we want things to be fair, usually some underlying set of outcomes will be equally likely, although in many games, some combination of outcomes are more likely than others. Take an example. Let's say we flip a coin and we want heads or tails. Does the outcome match your choice? Did you know before flipping the coin whether or not it would match? Statisticians don't think of randomness as an annoying tendency of things to be unpredictable or haphazard. Statisticians use randomness as a tool. But truly random values are surprisingly hard to get. It is surprisingly difficult to generate random values even when they're equally likely. Computers have become a popular way to generate random numbers. Even though they often do much better than humans, computers can't generate truly random numbers either. Since computers follow programs, the random numbers we get from computers are really pseudo-random. Fortunately, pseudo-random values are good enough for most purposes. There are ways to generate random numbers so that they're both equally likely and truly random. The best ways we know to generate data that give a fair and accurate picture of the world relying on randomness, and the ways in which we draw conclusions from those data depend on the randomness too. A simulation consists of a collection of things that can happen at random. The most basic event is called a component of the simulation. Each component has a set of possible outcomes, one of which will occur at random. The sequence of events we want to investigate is called a trial. Trials usually involve several components. After the trial, we record what happened, our response variable. There are 7 steps to a simulation. First thing, we're going to describe the possible outcomes. We're going to link each outcome to one or more random numbers. We're going to choose a source of random numbers. Then we're going to choose a random number. Based on the random number, note the simulated outcome. Repeat steps 4 and 5 multiple times, preferably until the outcomes show a stable pattern. Then we're going to analyze the simulated outcomes and report the results. So let's take an example. If an airline passenger is stopped at a security checkpoint in the terminal, the probability that the passenger has illegal contraband hidden in their luggage is 0.18. A police officer manning the security station plans to thoroughly search the luggage of all passengers who have stopped for a search until he finds one with illegal contraband. In A, we're going to use simulation to estimate the probability that illegal contraband will turn up before he searches the luggage of the 10th person who has stopped for a search. We're going to conduct 5 trials. Then we're going to calculate the exact probability that illegal contraband will be found before the 10th person who has been stopped has been searched. So here we have a random digit table. And we're going to start with row 1, and we're going to use these random digits. So in our 7 steps, of a simulation, we were going to assign 00 to 17 as luggage that has contraband. That's going to be our 18%. And 18 to 99 as luggage that does not have contraband. We will select a 2-digit number until 00 to 17 is selected or 10 bags have been selected. Once I have selected a bag with contraband or 10 bags, I will stop, and that is considered one trial. I start the next trial where I ended the previous trial, and then I will conduct 5 trials. So what I've done is I've described how I'm going to do the simulation and where I've assigned my numbers. This is the 7 steps to a simulation. So in our first row of random digit tables, I've got 84, which is no contraband, and then 17, which is contraband. So since I have selected a bag with contraband, I will stop. So I have done 1 trial, and I have found contraband within the 10 bags. In my second trial, I'm going to start where I left off. So I have 70, 67, 57. So there's 3 bags that have no contraband. And then 17 came up again. So again, I have found contraband. So there's my second trial. For my third trial, I have 51, 31, 55, 82, 51, 50, 68, 19, 25, 41. So I've gotten through 10 bags and did not find any contraband. So I stopped my trial. Alright, for my fourth trial, my first bag is 5, which is contraband, so that's a trial. And then finally, for my fifth trial, I have 9, and again found contraband. So there is my simulation. So in 4 out of the 5 trials, I have found that 80% I have found somebody with contraband. Now, second example. For each time up at bat, a baseball player has a 70% chance of making an out, a 10% chance of getting walked, and a 20% chance of getting a hit. Estimate the probability that out of 5 at-bats, the player gets at least 1 hit. Use 5 simulation runs. Alright, so now I have to describe how I'm going to do my simulation. So this time I'm going to start on my second row of random digits. I will assign 0 as a walk, 1 and 2 as a hit, and 3 through 9 as an out. I will select 5 one-digit numbers. I will count the number of hits and stop. And that is one trial. I start the next trial where I ended the previous trial, and I will conduct 5 trials. So I decided I'm going to assign 0 as a walk, 1 and 2 as a hit. I didn't have to pick those numbers. I could have picked 3 as a walk, 5 and 6 as a hit, and all the other numbers as outs. But I wanted to make it simple. So here's my second row of random digits. In my first trial, the first 5 numbers, I have found that I have 2 hits, because there are 2 ones. Alright, so I've gotten 2 hits out of my 5 at-bats. In my second trial, I have 8, 4, 4, 6, 9, which are all outs, so there are 0 hits. In my third trial, again, I've gotten numbers between 3 and 9, so again, no hits. My fourth trial, again, numbers between 3 and 4, so 0 hits. And in my last trial, I again have 2 ones, so there's 2 hits, so I've found 2 hits. So, in 2 of the 5 trials, which is 40%, I have 40% of getting at least 1 hit in 5 at-bats. Alright, in our third example, there are 28 people in class. I will randomly select 5 different people to receive a free snack. I'm going to run 3 trials to determine who the 5 lucky winners will be. Alright, so this time I'm going to start in my third row. Alright. So, my description of my simulation, I will assign 0, 1 to 28 as the people in the class. Numbers 0, 0, and 29 through 99 will be ignored. The reason I'm going to ignore them is because I only have 28 people in class and they're going to be all assigned a number. And if I get a number that's not between 1 and 28, what do I do with them? I will select 2-digit numbers until I have 5 that are from 0, 1 to 28, and that is one trial. I will continue where I left off and continue to the next row if I need to. If a number is selected again in a trial, I will ignore it since 5 different people must win. Alright, so in our first trial, I have 13, 11. I have 97, which isn't between 0, 1 and 28, so I ignore that. I have 10, 20, 85 and 94, which are not in my range of numbers, and then 9. So there are the 5 people that are going to get a snack. 13, 11, 10, 20, and 9. That is one trial. Alright, in my second trial I have 19, 32 is not in our range, 6, then I have 48, 87, 49, 87, 54, 35, 55. All those numbers are not in my range. Then I have 27, then I have 4. Now I've come to the end of the row, so I'm going to go to the next row and continue. 94 is outside my range, and then 26. So that is my second trial, and my winners are 19, 6, 27, 4, and 26. Alright, in our fifth trial, 80, 88, 44, not in our range. 26 is a winner. 29, 46, 47, 59, out of our range. 8 is a winner. 98, 95, 70, outside our range. 24 is a winner. 97, outside our range. 28's a winner. 40, then 6. So now I have found my 5 winners. They are 26, 8, 24, 28, and 6. Now, in this case, I didn't come up with the same number within each trial, so I didn't have to ignore it, but I do have to address it in my description. Okay, so what can go wrong? Don't overstate your case. Always be sure to indicate that future results will not match your simulated results exactly. Model the outcome chances accurately and run enough trials.